Hi, my name is Randy Magayon and I am the project manager of our Capstone project.
I'm Mark Anthony Macarayo. I am the documenter and researcher of the Capstone group.
Hi guys, I'm Ulysses Manigo and I'm the system analyst and the programmer of our Capstone project.
Good day. I am Jomar Asilo, and I am the system analyst and programmer of our Capstone project.
Good day. Now we are going to discuss our system entitled of Good Samaritan Diagnostic Hub Incorporated Information System. So, and our objectives are the general objectives. The project aims to develop GOODIS information system for Good Samaritan and Diagnostic Hub Incorporated. And our specific objectives is to record the client's personal detail, provide audio-visual cue management for client, compute and record payments for the laboratory examination fees, enable medtech to add laboratory result detail to client's record, enable medtech to send the notification of the laboratory result availability through SMS, then generate the following reports, so official receipts, client laboratory results, income daily statement, daily, monthly, or annual, then total numbers of clients by daily, monthly, or annual. So our project scope and limitations are: the project aims to develop a Good Samaritan Diagnostic Hub Incorporated information system to develop and improve and enhance the service and transaction made easier and faster. So the Good Samaritan Diagnostic Hub Incorporated Information System or GOODIS provides three accounts: the admin, cashier, and medtech. Under these accounts are composed of four modules: the administrator, cashiering, medtech, and client. So first, the client module function allows user to record personal details and provide audio-visual cue management for clients. So next is cashiering. The 5 cashiering can only be used by the cashier and admin account. This module is used to compute and record payments for the laboratory examination fees, and also to generate the following reports such as official receipt, income statement reports, and the total number of clients reports. Next is the client module function allow users to record personal detail and provide audio-visual cue management for client cashiering, and cashiering can only be used by the cashier and admin account. This module is used to compute and record payments for the laboratory examination fees, and also to generate the following reports such as official receipts, income statement reports, and total number of client reports. Next is medtech. This module can add laboratory result details to client records, provide audio-visual cue for clients, and send notification of laboratory result availability through SMS. This can only be accessed by admin and medtech officers. Next is administrator. The function of administrator is to access the records client details, manage the audio-visual cue for the client, and use the cashiering module to compute and record payments for the laboratory details for the laboratory examination fees. It can also use the medtech module and to add laboratory result details, clients records, send notification of the laboratory results availability through SMS, and print all the generated report from the system. In general, the administrator module can access the entire module of the system. For the limitation of the Good Samaritan Diagnostic Hub Incorporated Information System, payroll system is for its employees is not included in the system. The diagnostic center offers drug testing, but only the queuing part of the processing is included. The system includes the recording of drug test results, since there is a mandate system to be used nationwide.
Is the methodology and explains the techniques and strategies that were used by the researchers in developing the information system of Good Samaritan Diagnostic Center. The group utilized the SDLC or Software Development Lifecycle Strategy for a framework to be made. which includes planning, analysis, design, implementation, and maintenance stages. For example is existing system business process, DFD or data flow diagram, use case diagram, technologies and tools used, system implementation. Existing system business process. The existing system process is shown in Figure 7. The Good Samaritan Diagnostic Center has been operating for many years now. The traditional paper-based data filling is still the process of the current system. The client needs to fill up a registration form for client profiling for the lab request. The registration forms will be directly stored in a cabinet full of paper that can be glossed, crumpled, and teared. The clerk will check the client details and the corresponding payment bills. After the payment is settled, the collection of specimen will be collected and it will undergo some analysis. Then the result of the specimen analysis will be released to the client. So the first step is fill up registration form. Next is payment. Next is collection of specimen. Next is specimen examination and analysis. And the last one is releasing of results. For the DFD or data flow diagram, the diagram shows the specific process involved in every interaction of the user happened and how the data is used in the process. We have here the client. So the first process is to add and update client record, and it will be stored in the GOODIS database. For the second process is assigning queue number. So from the GOODIS, the assigning queue number will be given to the clients and will be stored to the GOODIS database. Next is add and update payment record. The clients will pay for their bills, and the payment record will be stored in the GOODIS database. Next process is the add update client laboratory record, and will be controlled by the method. And the next one is the third process is add update payment record, and the fourth process is add update client laboratory record. The fifth process is notify laboratory result availability that will send notification to the clients. And the last one is generate report daily, monthly, and annual. Use case diagram. The developers show the full functionality of the system and illustrate the actor, which is the user, and the use diagram. The diagram represents the interaction between the actor and the system. So we have here the client. The client will request for laboratory result test. The use case diagram. The developers show the full functionality of the system and illustrate the actor, which is the user, and the use diagram. The diagram represents the interaction between the actor and the system. So we have the first actor, which is the client. The client will request for laboratory test or view list of laboratory test, fill up registration form, get priority number, make payment, receive SMS notification. The second one is the clerk, which will print official receipt, check client details, make payment, and to log in for the system. Next one is the medtech. Will encode laboratory result details, check client details, and of course to log in the system. And the next is the manager or the admin will need to log in and generate report or income report or number of client report. Technologies and tools used. We have SAMP control panel for the local host, Visual Studio 2015, the application used, Adobe Photoshop, Laravel framework, and Twilio for the SMS. System implementation. After all the prerequisites were being gone along, developers displayed the yield to the board of panelists for important suggestions and rectification for the improvement of the system. After the system was introduced and evaluated by design panelists, the gathering archived such proposal and suggestions for the exactness of utilization of the system. At that point, the designers executed the system so as to be successfully utilized by the user of the diagnostic center. To test the efficiency of our project, the developers deployed software project system implementation. After all the prerequisites were being gone along, developers displayed the yield to the board of panelists for important suggestions and rectifications for the improvement of the system. After the system was introduced and evaluated by the design panelists, the gathering archived such proposals and suggestions for the exactness of utilization of the system. At that point, the designers executed the system so as to be successfully utilized by the user of the diagnostic center. To test the efficiency of the project, the developers deployed the software project from March 2 to April 17, 2020 to identify different errors and malfunctionalities. The allotted time was the basis of the developers to meet the needed requirements and expectations to solve the other encountered problems. The developers conducted a proper orientation about the different functions and characteristics of the project to the system and users. Some adjustments and changes were made. In cashiering module, the audiovisual cue from the cashier has been removed as advised by the owners of this establishment, and solutions were formulated to address the identified errors. During implementation, the developers clarified the system flow to Good Samaritan Diagnostic Hub Incorporation. After the discussion, the end user attempted to enter information and check the usefulness of the framework. The end users posed some inquiry and gave proposals that will make the framework increasingly dependable. The developers wanted to disclose the framework to all users when they evaluate. To test the accuracy of the functions of the project, the developers decided to use different testing methods such as unit testing and functional testing for defect tracking and describing the resolution. Also, the testing activities were used to identify software bugs early and to ensure that system requirements meet the client's needs. Results. During the execution stage, the development team let the end users to use the system as indicated by their tasks and functions. The development team put together their outline results with respect to the assessment sheets and counted the score in like manner. So, in assessment description, number 1 is record the client's personal details. And the final average is 4.3, and the descriptive equivalent is efficient. Number 2 is provide audiovisual cue management for client. 4.4 efficient. Compute and record payments for the laboratory examination fees. 4 efficient. Enable medtech to add laboratory results details to clients' records. 4 efficient. Enable medtech to send notification of the laboratory results availability through SMS. 4 efficient. Generate the following results. Reports. 3.25 moderately efficient. Official receipts. 3.5 moderately efficient. Client laboratory results. 3.5
moderately efficient. Income statement, including the daily, monthly, and annual. 3. Moderately efficient. Total number of clients, including daily, monthly, and annual, is 3. Moderately efficient. And the total AVM is 3.75. Moderately efficient. Conclusion. To face and handle several challenges along the way, the Good Samaritan Diagnostic Hub Incorporation is looking towards the IT sector for the automation of the old system of the establishment. The establishment old system has several problem difficulties in assisting the bulk of clients, delaying in answer clients' laboratory test results due to handwritten forms is poor quality or illegible handwriting, and time-consuming in issuing reports. The developer implemented and designs a system named Good Samaritan Diagnostic Hub Incorporation Information System or GOODIS to aid the problem. The designers utilized the System Development Lifecycle or SDLC strategy prototyping model for building up the application. The technique incorporates a progression of stages. The stages incorporate planning, analyzing, designing, implementation, and maintenance. After evaluating the users, the system received an average rating from the user where they found out that system is useful and moderately efficient in every function it has. The system helps the demonstrative place in the client's data assembling quicker and effortlessly. Gathering papers and working time will be lesser and labor will be considerably more proficient. By the improvement of the data system, the Good Samaritan Diagnostic Hub Incorporation procedure will be supported by the system. Recommendation. In light of the outcomes and evaluation given by the users during the implementation, the users praised the yield of the framework and no other proposal expressed. Along these lines, the developers of the Good Samaritan Diagnostic Hub Incorporation might want to suggest it. The framework ought to be installed in a PC unit that has at any rate 4 GB RAM to ensure that the framework will run adequately. The developers additionally settled recommendation for upgrading the framework in the future turn of events. For the future developers of the task, the developers recommend the accompanying 1. Add finance framework. 2. Add a statistical graph for all the total number of clients and for the income statement reports. 3. Add security modules and measures to ensure the data and the framework. 4. Backup and restore feature. This feature will help the diagnostic center to recover data from an unplanned event. Storing important copy of data on a separate storage device is critical to protect against data loss or corruption.